All right, so now we're going to talk about when linear equations in one variable have one solution, no solutions, or infinitely many, or all the solutions. To do that, I've got two examples up here that I'd like us to work and see what happens. So for this first example, 3x plus 3 over 12 minus x minus 2 over 4 equals x over 3 plus 2. Let's find our common denominator, our least common denominator, which in this case, if I look at 12, 4, and 3, 12 plays nicely with all of those, where 12 is the least common denominator. I'm going to multiply both sides of my equation by 12 to clear the fractions. That's going to just make it easier to solve, okay? Now remember, when I'm multiplying both sides by 12, I have to multiply each term in here by 12. In the last video, I explicitly did that. Now I'm going to try and do that kind of a little bit shorter method. When I do 12 times 3x plus 3 over 12, the 12's cancel, and I'm just left with 3x plus 3. Now when I do 12 times x minus 2 over 4, well, 12 and 4 are going to cancel and leave me with a 3. So I'll have minus 3 times x minus 2. On the other side of the equation, when I do 12 times x minus 3, 12 and 3, I'm going to get cancellation, leaving me with a 4, so I'll have 4 times x. And then lots of people forget this step. I also have to multiply this 12 times 2. 12 times 2 is 24. So when we multiply by our LCD, 12, we clear the fractions. Now let's go through and solve this. First thing I'm going to do is distribute that negative 3. So I have 3x plus 3. Negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6 equals 4x plus 24. Now I'm going to combine like terms. Over here I have 3x minus 3x. Those cancel. And I have 3 plus 6, that's 9. So I have 9 equals 4x plus 24. I'm going to get all my x's on one side, my non-x's on the other. I've got my x's over here, so let's go ahead and move the 24 to the other side by subtracting 24. 9 minus 24 is negative 15. So I have negative 15 equals 4x. Dividing both sides by 4, I get negative 15 fourths equals x. Quick check, there's no common factors there, so there's my answer. This is an example of having one solution, right? If I plug in negative 15 fourths to that equation, I will get my equality to hold. In other words, I'll get the same thing on both sides of my equal sign, okay? Now, let's look at our second example that we have up there. So in order to solve this guy, let's distribute 3 times x is 3x, 3 times 2 is 6, minus 7 equals 2 times x is 2x, 2 times 4 is 8, plus x minus 9. Collecting like terms, I'll have 3x, 6 minus 7 is negative 1. I have a 2x and an x, that's 3x. 8 minus 9 is negative 1. Anybody notice anything? Now if I keep going and think about getting all of my x's on one side, I'm going to subtract 3x from both sides. Notice that I've got 3x minus 3x, that cancels, leaving me with negative 1. 3x minus 3x, that cancels. And I'm left with this statement, negative 1 equals negative 1. Now the question is that a true statement? Well, yeah, negative 1 does equal negative 1. So when we get something where there's no more variables, all of our variables fell out or canceled out. No more variables, but what we have left is true. This is what's known as an identity. An identity is always true. This is always true. In other words, any x that you pick, any value of x that I pick, is going to make this true. Let's try it. Let's pick x equals 0. If we plug in 0, okay, I'm on the board, so I get to do this, right? If I plug in 0 for all of my x's, let's see what happens. Okay. Well, I'll have 0 plus 2, which is 2. 2 times 3, which is 6. 6 minus 1, which is negative 1. 0 plus 4 is 4. 4 times 2 is 8. 8 plus 0 is 8. Minus 9 is negative 1. Huh, look at that. That's definitely true. Now let's pick another number. I'm going to pick 1 because it's fairly easy to work with. So now I'm going to let x be 1. In other words, I'm going to replace all of the x's with 1, and let's see what happens. All right, 1 plus 2 is 3. 3 times 3 is 9. 9 minus 7 is 2. So we end up with a 2 on this side. Over here, 1 plus 4 is 5. 5 times 2 is 10. 10 plus 1 is 11. 11 minus 9 is 2. We still get equality. Any value that I pick, any number, 3 halves, negative 3 halves, negative 1 million, positive 1 million and 2, if I plug that in for x, I'm always going to get equality, right? That's because when we solved this, our x's went away and we were left with something that's true, okay? So in an identity, all of our variables fall out and we're left with a true statement. Negative 1 equals negative 1. An identity is always true. That means in interval notation, if I want to say which numbers are true, which numbers make this true, or which x values make this true, well, all of them. How do I say everything in interval notation? Well, I do negative infinity to infinity, okay? So this is an example of an identity, okay? Now, this guy, which was similar to everything that we looked at before, is an example of a conditional. Why do we call it a conditional? Well, it's conditionally true, right? That means it's sometimes true and sometimes not true. This equation is conditionally true if we pick x to be negative 15/4, but it's not true if x is 7 or if x is 0. So this is an example of a conditional. Now there's one other type of equation up there. So let's talk about that real quick. All right, so now we kind of want to look at that last example, okay, a contradiction. Now, what does that word contradiction mean? Contradiction means something that isn't true or something that's false. So let's look at this example to get an idea of what happens in a contradiction. Now, if I want to solve this, I'm going to start by distributing. 3 times 4z is 12z. 3 times negative 7 is negative 21. 6 times 8 is 48. 6 times 2z is 12z minus 12. Okay, I'm going to simplify by collecting like terms. I've got 12z minus 21 equals 48 minus 12 is 36 plus 12z. Yeah, maybe you're starting to notice something here. I'm going to try and get my z's on the same side. So I'm going to subtract 12z from both sides. Well, 12z minus 12z cancels, and I'm left with negative 21 equals 12z and 12z cancel, 36. So just like over here in our identity, my variables fell out. I don't have any more variables. But here I was left with something true. Negative 1 does equal negative 1. What about this? Is this true? Negative 21 equals 36. Well, that's false. That is not true. Okay? So this is a false statement, also known as a contradiction, something that is not true. So this is an example of a contradiction. All of our numbers fall out, all of our variables fall out, and we're left with a statement that simply isn't true. Okay? This is an example of a contradiction. Okay, a contradiction. And what's our solution here? Well, our solution is nothing. It does not matter what you plug in for z. Negative 21 is never going to be equal to 36. Never. You can't pick a z to make that true. So our solution is there are no solutions. No solutions. You know, if you want to get fancy, you can use this little symbol, which means the empty set, the set of nothing. But we can just say there are no solutions. Okay? So I'm going to go ahead and summarize what we know about contradictions. All right. So now I've summed up what we know about all three of these. Conditionals, these are kind of the normal type of equation that you've probably seen most frequently in the past. When we go through solving them, we end up with an answer like our variable, say x, equals a number. Okay? In other words, these have one solution. Identities, our variable falls out, right? Our variable went away. They canceled out as we were in our process of solving, but we're left with something true. 2 equals 2. 0 equals 0. Negative 1 equals negative 1. Our solution in this case is everything. We write everything in interval notation as negative infinity to infinity. One way of thinking of this is there are infinitely many solutions. Everything is a solution, okay? And last, contradictions. Now, similar to identities, when we're doing a contradiction, our variable falls out, or our variable cancels out, and we're left with no variables. However, what's left is false. Negative 21 equals 36. 7 equals 5. A false statement. In this case, there are no solutions. We can write that using the fancy empty set notation. But another way of thinking about this is there are 0 solutions or no solutions at all. Okay? So conditionals, identities, and contradictions, we'll see that we can classify any linear equation in one variable as one of these types. Is they're going to be conditional, have one solution, be an identity, have infinitely many solutions, or be a contradiction, have no solution.